I'm afraid that there's going to be too many jobs available, but they're all going to be in elder care.
Are you ready? All right, let's go.
Manufacturing is sexy. Sounds crazy? Just wait. I'm Z Holly, host of The Art of Manufacturing. Your behind-the-scenes look at how people who make stuff are trying to make it in their industries. If you've ever wondered how to build a brand, a business, or just a better mousetrap, tune in and enjoy. This week's episode busts some myths about robots, artificial intelligence, and the future of the workforce. I've been really curious about the topic and how it impacts manufacturing. In fact, you might remember the episode on automation with Nick Pinkston a couple months back. Well, if you own a Roomba, you can thank our next guest, Rodney Brooks. He's the robotics and AI visionary that co-founded iRobot. I knew him way back when he was a professor at MIT, launching the company with my classmates Helen Grainer and Colin Engel. Well, today, he's at it again. He's trying to disrupt the world of industrial robots with his new startup, Rethink Robotics. I was in Boston a few weeks ago and visited Rod at his home in Cambridge. And he shares some great stories from his long career which inspired his new company. He tells us about the hype of AI and the potential of collaborative robotics. We hear about the pending workforce shortage. Wait, what? Yes, you heard that right. Workforce shortage. And why location matters with manufacturing. He shares humbling lessons about finding product market fit he learned the hard way, over and over again. I'm surprised to hear how difficult it's been to get robots onto the factory floor. But he's finally onto something, and his ideas might help save the manufacturing industry. We hear about that and a whole lot more on this week's episode of The Art of Manufacturing.
Rethink Robotics is about using robots in the 90% of areas of manufacturing that do not use robots currently. And it was really driven by seeing both in the United States and China that labor was starting to get shorter and shorter. And people often don't think about that in China. But compared to what it was like in the 90s, labor is in very short supply now.
That's very counterintuitive. Most people think that the labor is cheap in China and, we can just send things over there and have it done by hand.
If you look at the demographics, we're right about in the middle of a 10-year period when the absolute number of 19-year-olds in China is reducing by 30%. It's an effect of the one-child policy. 19-year-olds is roughly where the manufacturing labor comes from. And by the way, the standard of living and education has gone up. So people don't want those manufacturing jobs. There's a whole other economy there for the people on the coasts and quite a way in. And it's getting harder and harder to get people who want to work in those really monotonous manufacturing jobs in China. They're much more monotonous the way they're set up than U.S. manufacturing jobs.
So what does Rethink Robotics do then to solve that problem?
So for both geographies and for Europe and Japan, where we also sell a lot of robots, we have a robot. We first had Baxter, now we have Sawyer, a second product, which is safe to have right next to a person. Because one of the costs of putting robots in, and the reason it's only been done in certain industries, is that traditional industrial robots, starting with the first ones that were installed in a GM plant in New Jersey in 1961, back when sensors were incredibly expensive and computation was even more expensive. So those original robots didn't sense the world around them, and so they were not safe to be next to because they didn't know if you were in the way, the hydraulic system just kept going and you kept going. So we've built robots that are safe to not be caged away from humans, and that means that you don't have to rip everything out and get rid of all the people and go with all robots. You can mix people and robots together. So that gives you an incremental way of bringing in robots for some tasks that they can do, but still have people around for the tasks they can't do. And it's, by the way, in our experience, it's not about getting rid of people. It's about filling holes in the labor force. Mm-hmm.
So what are some of those holes that, in comparison to things that humans can do versus what robots are good at?
So it's not necessarily filling particular holes. It's if we can get the robots to do the more monotonous, non-value add sorts of things, then the humans can do the value add things. So a lot of our robots are doing machine tending. They're sitting in front of some expensive machine, They're putting something into the machine and then sitting there waiting until the machine is ready for them to take it out. And generally, these machines are expensive, so you don't want to miss any of the cycle time on the machine. So you have a person there all the time whose main job is to wait. Well, robots can wait just as well as people can, and so long as we can interface easily to those machines, and the way we interface is by having our robots slide the doors, the safety doors, just the same as a person would, use the same interlock system, press the same buttons, and wait for the same green lights or the same message on the screen, and use the cameras on the robot to see when it's done. So we try to avoid having to do systems integration, because that slows everything down in terms of deployment.
So what do the humans do then?
And then the humans do things where they're not sitting around waiting all the time, where it's more cognitive, where it's more dexterous. And because, robots, in an unstructured environment where you're not spending a lot of money on systems integration, you're not going to get the robots to do anything particularly dexterous today.
I noticed that Baxter and Sawyer, they look like humans. What's the thinking behind that?
I wanted to make the robots be approachable. So not only do they, to a certain extent, look like humans, but an ordinary factory worker without any training can get them to do simple tasks, because I didn't want it to be that the robots were these sort of black boxes that management brought in and were separate from the workers. I wanted it to be a tool for the workers. You don't hear people who work in houses putting up plaster walls and things like that, carpenters. You don't hear them saying, oh, the electric drill is taking away jobs from carpenters. They use it as a tool. They use it to be more efficient. And so I wanted the people who are in the factories to feel like these are tools that they can approach. The humanish form, is important for a couple of reasons. One, if they're interacting with machines the same way people do, they roughly need to be the same size as people. Although people use their hips to bend a lot. And so in Sawyer, even though Sawyer is a smaller robot than the original robot Baxter, it has actually got a longer reach because it has no hips. And in order to be able to reach the same as a person who's in one place can reach, it has a longer reach. But the other thing is, on the screen of the robot, we have artificial eyes, graphical eyes, and the robots glance where they're about to reach. So people around them are never surprised by their motions. It's not like the robot is doing something unfathomable, because instead, just like a person always glances when they're about to reach somewhere. And we don't have to train the workers to know that. They pick up on that within a day. If you ask them, what are the eyes doing? And they say, it's looking where it's about to reach. It's something that we are so attuned to. We do it with our animals too. We know where our animals are looking. We know what's going on.
What's been the market response to the product, to the robot?
I say that what we're trying to do is drag manufacturing into the late 20th century. I think in Silicon Valley, the people think if you've got a technology that can do something, it's just going to get adopted, and it doesn't get adopted for a very good reason. Manufacturers are conservative because they're all busy producing stuff, and they've got things that they have to do.
And they've invested in a lot too.
They've got a lot of equipment already. They don't want to take it offline while they try something new. So it's a long sales cycle for us, and I was not expecting that. I was expecting, people see the ROI, because the ROI calculations for most people are pretty straightforward. It's gonna have an impact, but the disruption, the change, that's a lot slower.
So talk to me. I'm a manufacturer, let's say. What's the ROI? How do you cost it out?
In the US or Germany, it's pretty straightforward. A single shift, you can within a year it's cost less than getting another person in, if you can get another person in. If you're running 2 shifts, it's less than 6 months. In China, it's about a year or a year and a half, depending on what the shift time is. The ROI works when the task that you're doing is one that the robot can do. So one of the things we see is people get a little too excited and say, I'm going to get the robot to do this task. And we say, no, that's going to take a lot of work to make it reliable. And sometimes they buy a robot and then they get disappointed. So we've got this whole checklist that all our field application engineers go through, that our salespeople go through. And we're trying to say, don't go for the really hard task. Go for the easy task, because that's where you're going to get satisfaction more quickly.
And that's the point, really, is to do the repetitive.
Do the repetitive, simple tasks. Yeah.
Interesting. I mean, I'd love to get back to also later about how do you sell, how do you get market adoption for something that's a real change. But I want to take a step back for a second and ask you a little bit about your path. So I knew you as a MIT professor, not as an entrepreneur way back when. So what's that path been like for you becoming an entrepreneur?
Well, actually, the week before I joined the faculty at MIT, I started a company in Silicon Valley. So I was technically an entrepreneur before I was an MIT professor. I've had companies all along. When I was an MIT professor, I started with 2 students in 1990, iRobot Corporation, which, if you think about it from the point of view of what every entrepreneur is taught, we were the worst possible things. We had a technology and no market, but we were sure the market was there. And 14 failed business models later, we finally found 2 markets in the same year. So we started in 1990. In 2002, we brought out the Roomba, which has now sold over 20 million Roombas, and we brought out the PackBot, which we had 6,500 PackBots in Iraq and Afghanistan doing roadside bomb disposal. And now, 27 years after we started, the market cap's about $2.5 billion.
Amazing. And isn't it true the Roomba is the largest deployment of robots ever?
The Roomba is the biggest selling robot ever, if you include all the models. Now, by the way, there are probably about as many other home robot vacuum cleaners as Roombas. So totally there's 40 to 50 million robot vacuum cleaners have been sold.
But that wasn't your first startup. So tell me about your first startup.
My first startup was a company called Lucid, Lucid. It was a software company based in Palo Alto, and then we occupied the top floor of Menlo Park City Hall for many years. Now, I'm not sure whether listeners of this podcast would know that in the late 70s, early 80s, the MIT Artificial Intelligence Lab developed something called Lisp machines. There were special purpose machines to run an AI language called Lisp.
I remember having to program in Lisp.
And those machines let you do AI great, but I was able to see that with all the engineering that was going into other personal machines. By the way, those Lisp machines were $100,000 a piece. But so were the first Sun workstations. They were $100,000 a piece. But I could see that so much engineering was going into the processors for the other workstations. And during the 80s, there were massive numbers of companies building workstations. There was Apollo Computer. There was Prime Computer. IBM had workstations before the PC and around the PC. I could see that all the engineering that was going for general purpose workstations meant that a software solution would ultimately beat out the hardware solution. I built a software system for Lisp running on an early Sun workstation, and then we turned that into a company. And the company ultimately supported software on 19 different platforms.
Really?
And between 1984 and 1992, it was VC funded, sold a lot of units, and then went Chapter 11. And it went Chapter 11 when people decided C++ was a better standard than Lisp.
Yeah. So what did you learn from that experience that you carried forward in your future endeavors?
Well, obviously I didn't learn a whole lot because I started a company that had no customers, but now I realize you got to understand who the customers are and what's going to help them. But I still like to do things so much on the edge that it's still hard work getting there.
How long did it take for you to get to the point where you realized that, selling Baxter is not going to be as easy as I thought? What was that like?
That was the first year after we started selling. Yeah, it was a tough year.
So how did you learn about manufacturing? So you went from IT.
When I started iRobot in 1990, we were actually a space exploration company. That was our initial charter. But we had many failed business models.
You are ahead of your time.
Yeah. We actually did a launch in 1993. Anyway, in 1997, we were really pushing on the idea of robot toys. And I started to learn about how toys were manufactured in China. And we eventually teamed up with Hasbro on a robot called My Real Baby. It was a doll aimed at the girls' market, a humanoid doll, and with facial expressions, voice, laughter, responsiveness to being tickled, responsiveness to changing its diaper, etc. And we built that in China. And so that was my real introduction to manufacturing.
And how did you learn the ins and outs of that? Did you spend time in China?
Initially, before we teamed up with Hasbro, we were trying to team up with a whole bunch of other toy companies, smaller companies in general. And it was 1997. I could probably figure out the exact date because it was just as Hong Kong was handed over from Britain back to mainland China. I was in Taipei at the time, working with an expatriate British guy who built toys, and at that time he was building something called the Tamagotchi. I don't know if you remember that.
I had one.
Little handheld thing that you had to look after.
I had killed it.
Yes. and I remember sitting with him for days and days, and he just sat at a big empty desk. He had no spreadsheets, and he would just make telephone calls. And he'd say, I need 8 million of these particular plastic cases. What do you mean 4 cents each? I'm not paying more than 3.5 cents a piece. And he was just this old time guy arguing with all his suppliers and getting all the pieces together in mainland China from Taipei. And that's where I learned about how if you had a microprocessor in there, it would be a tiny little microprocessor, that was your key IP. And you had to stop that getting stolen from someone else. So they would have at Taiwan Semiconductor Manufacturing Corporation in Taiwan, they would build little tiny microprocessor chips and have them, thousands and thousands of them in a plastic case, which they would then handcuff to their hand. And someone would take that by hand to the factory in China where everything else was getting built and everything else could get copied easily. Mm-hmm. And then at the last minute, install those chips into the product. So it was the Wild West. It really was the Wild West. And so we started working with a company which at the time mostly made plastic toys for McDonald's Happy Meals. And we helped them see their way through to building electromechanical systems, which they still do today.
Wow. So how did you decide to go with that manufacturer?
We decided at that time, we used manufacturers that were based in Hong Kong, were owned by a Hong Kong family, but operated just across the border for the lower labor costs at that time.
Back then, so Shenzhen, I assume.
Yes, but it wasn't like Shenzhen today.
Yeah, there was nobody there at that time.
Yeah. And then with my role at MIT, where I was head of the Computer Science and Artificial Intelligence Lab, sort of in a parallel universe, we were seeing big Taiwan-based companies like Delta Electronics, Acer, Quanta Computer, who were building the laptops and even the servers that powered U.S. industry, wanting to change from being OEMs to having their own brand and having their own products. So they were coming to MIT and funding research. So I got to know the founders of all those companies and spent a lot of time with them and saw how they were doing manufacturing in a much more sophisticated way. And they, those companies build stuff for Apple today still, besides having their own brands.
So a humanoid doll. That sounds kind of creepy, actually. I don't remember seeing that coming out of iRobot.
Well, it was. I'll show you one. Okay. It can't be on the podcast, but I will show you one.
We'll show pictures. So what?
And some people thought it was really creepy, by the way.
Yeah, but I didn't. Did it I mean, did it sell? Because I don't remember seeing it.
It was not a great success.
No.
And we attributed that to Hasbro not knowing how to market it. And we also realized that the toy industry is sort of a Ponzi scheme. The toy industry works by getting individual inventors to come and pitch their ideas, and then the toy companies select the ones that they like, but they haven't paid for the development costs of getting the toy. And so if you are a toy developer, you mostly work as an independent contractor, and your expected income is negative. But some people hit big. And we were trying to build a business model around that and realized that toys was not the thing to do.
So how did you get from there to automation? What was the inspiration for that?
Well, when we finally hit upon the Roomba, which used a lot of the same technology we had developed for building toys, to get the price down, we used plastic gear trains, all sorts of things that other vacuum manufacturers were not thinking about, which is how we came out at $200 in 2002, when there was already a robot vacuum cleaner on the market, the Electrolux Trilobite, which sold for 2,000 euros.
Really? So there was one on the market?
There was one on the market before us, yes.
Okay.
They were very upset with us because when we undercut their price so much. But we had looked carefully. We were not infringing on any IP. We had a very different way of building them. So then I really got involved in manufacturing our own products in China. And through these other companies I was working with at MIT and seeing how they manufactured their products. And then I started to see the signs from our own experience and from these companies that I was talking to, that they were seeing the infinite supply of labor starting to change in around 2004, 2005, way before it really became noticeable, but the early signs were there. At the same time, I was on it was called the Global Technology Innovation Advisory Council of GTIAC, of John Deere & Co. And so I worked with John Deere with a bunch of other technologists on this advisory group, and ended up going to lots and lots of John Deere factories all over the US and lots of John Deere places all over the world. And I saw how their manufacturing in the US was suffering from an aging workforce and from urbanization, because a lot of their factories are out in small towns, which most of the elite on the coasts, the elite in quotes, have never heard of. But the young people were leaving those towns. So John Deere was seeing an aging workforce without younger people joining the workforce in those towns. So I was sort of seeing a bunch of signs that labor was going to get short.
Well, it's so crazy because we hear the exact opposite. We hear that jobs are disappearing, both they're being outsourced, jobs are disappearing because of automation. And so why is there this disparity?
Well, there's not in a sense, there's not so much of a disparity, but it's more complex. Everything is more complex than the simple thing. Yes, we stopped building TVs in this country. We stopped building lots of electronics in this country. So that did get outsourced. That got moved. First, it got moved to Japan. When labor costs went up there, it got moved to Korea. When they went up there, it got moved to Taiwan, and then it moved to China. It's not moving anywhere from China because China has built, over the last 30 years, an enormous supply chain. And the Chinese government knows that's an asset they have, and they will do anything to keep manufacturing within China. And so they're pushing into robotics like gangbusters. They're putting a lot of money into robotics so that manufacturers are not tempted to go and try and set up parallel supply chains in Vietnam, Malaysia, etc.
Well, this is a perfect example of why manufacturing isn't just about jobs. It's about national security. It's about competitiveness, innovation. So if you're just looking at jobs, you're going to lose.
Yeah, it's a very complex thing. People say, let's make Apple build the iPhones back in the US. Well, there's no supply chain that can support that in the US, and building that supply chain is a major infrastructure undertaking. If you're building a complex product, it needs a complex supply chain.
So what should we be making, and what are we making in the United States? And I assume you're working with a lot of US manufacturers.
Yeah, and we build our robots in the United States.
Great.
Yeah.
So tell us more about what should continue to, and what can we keep in the US? What makes sense?
I think we have to admit that complex electronics is gone and will take a long time to come back. But things that have material science involved in them, in mechanical parts, if you want sintered metal gears, the place to do that is Pennsylvania. There's lots and lots of companies that do it in Pennsylvania. Why? Because the technology was developed at Penn State University. So there's a whole bunch of companies geographically not too far from Penn State, and that's the best place in the world to build sintered metal gears. So there are technologies that we have in the US that you can't get other places. Realistically, though, even though we build our robots in the US, we get our electric motors from Eastern Europe because we cannot get the electric motors we want in the US, and actually Eastern Europe builds better ones than the Chinese companies. So, if you want a Mabuchi motor and the Roomba uses 5 of them, you buy them in China. But the brushless DC motors that we use in our robots, Eastern Europe. So you have to be aware of where things come from and be prepared to have a global supply chain, because you're not going to get everything in the US.
Why do you manufacture in the US?
We manufacture in the US for 2 reasons. Our initial market was US manufacturers, and it would seem weird if we were foreign manufacturers. But the other thing that happened was we have 2 major suppliers. We have suppliers all over who build cast metal parts and all sorts of pieces. But we have 2 major suppliers in Massachusetts, just a few miles north of Boston, and we do have a final assembly just over the border in Nashua, New Hampshire. That means where we are in South Boston, our engineers can be on the manufacturing floors of our 3 primary sites within an hour. Developing a complex product was so much easier than if it had been done a long way away. And we chose those places because they were geographically close to us.
So you outsource it then to those companies?
Oh, yeah, we outsource everything. We outsource everything, but it's largely U.S. companies.
Right. Is IP a consideration too when you decide who to work with?
We do take into account IP. We take into account IP from what people can learn about our robots, because they're physical devices. We try to patent the things that if they pull the robot to pieces and can see, we patent that. We haven't yet had to fight anyone on patents, but we do have a strong portfolio, a patent portfolio in the US, in Europe, Japan, China. And then the things that they can't see by pulling the robot apart, we keep trade secret, and we have a lot of cryptographic protection on all our software. And our software will only run on the robot it is designated to run on. It will not run on another robot, so it won't run on a copy because of cryptographic protection. So we really try hard to keep all that stuff trade secret.
What's your biggest market? Which country? Is it China?
Well, a year ago we thought it would be China, but then Germany has come on fantastically. So, and the US come on better than we expected. So, it's not one place taking off like crazy. It's going better than we expected in multiple markets.
We're taking a quick break, but first, I wanted to mention that we're almost done with season 2. Can you believe it? It actually makes me kind of sad because I love bringing you these conversations every week. But taking a break will let us build community and bring in more partners to make next season even better than the last. If you love this podcast, do me a favor and send me your feedback and tell your friends. The more downloads we get now, the better we can support the show in the future. And to make sure you don't miss future seasons, subscribe now on your podcast player. You're listening to The Art of Manufacturing. Join the conversation on social at We Make It in LA and our Facebook group, makeitinla.org/community. We'll be right back after this break. The Art of Manufacturing podcast is a collaboration with Make It in LA, which is generously supported by organizations like the LA Cleantech Incubator. LACI has a really cool facility in the Arts District of downtown LA filled with energetic startups and nonprofits. They offer cleantech startups flexible office space, epic prototyping labs, and the #1 rated cleantech incubation program in the world. Learn more at makeitinla.org/LACI. We're speaking with Rod Brooks, the AI visionary who's reimagining the factory floor with his latest company, Rethink Robotics. So I want to talk to you about the AI side of it. And so, of course, you've been a real pioneer in that area. And I'd love to hear about what principles are behind behind your innovations, and then where you see AI and automation going into the future.
We say, and it's true, our robots do use AI, but I think, an AI researcher who really saw inside our robot say, oh, that's so boring. And why is it so boring? Well, because we're building for a conservative audience who want the thing to work every time, which means we have to scale back our ambitions on what we're delivering so we know that it's 100% working. So we do use AI. We use AI in many different ways. When you're training the robot by demonstration, it's a little AI program that makes inferences about, how the robot arm was moved, what happened when the fingers closed. There's rule-based systems in there that then patch together and automatically program a program, inferring it from the interactions that the person training the robot, what they showed it. And it maybe is out of sequence how they trained it. So there's AI there. There's AI in the vision systems. They're using techniques that, when they were first published, were published in AI journals for vision, etc. Deep learning, machine learning, deep learning has really increased expectations for AI. It is undeniably delivered some things which no one thought would be around 5 years ago. It's had an incredible impact on the front end of speech systems, which is why the Amazon Echo, Google Home, Siri do speech recognition so much better than we had 5 years ago. In fact, when we started Rethink Robotics, we went and looked at speech systems, and we decided that it was crazy to put any speech interaction because the robot's going to be in noisy factories. And we estimated you could get at most 4 bits out of a person talking to it. That has changed drastically
really?
Now. You can now get real information from a person talking in a factory.
Even in the noisy environment.
So, and that's deep learning has done that. Mm-hmm. So that's great. But I think people, a lot of people make a mistake in overgeneralizing what deep learning can do. And I make the distinction between performance and competence. If we see a human being perform some task at some level, we have a pretty good intuitive model of what general competence they have around that performance. But it breaks down for these AI systems. So here's an example. Suppose you speak another language. You speak Hungarian. Okay. Suppose you saw a person sitting at a table and they had a stack of pictures and they were taking the top picture off and writing in Hungarian underneath the picture on the piece of paper what was in the image. People playing frisbee in a park, a girl on a swing, a speedboat. If you saw a person doing that, you would think they understood Hungarian. You would think that if they saw a Hungarian sentence, they would know what the Hungarian sentence meant. You'd probably first think that they could speak Hungarian, but let's just say you'd at least expect them to be able to read Hungarian. That would be a natural thing. But these AI systems that label images in Hungarian, and they do, or Chinese or Japanese or English, can't read those languages. It's not understanding it in the same way we understand it. I think people have seen, especially people outside AI, have seen the performances and think that the systems can do so much more than they really can. They're very narrow point solutions. They take real work to get working. When they do work, they're fantastic, but we don't know exactly what they're going to work for ahead of time. So I think we're seeing a little bit of a bubble right now. A lot of VCs say, well, just apply AI to that problem and it'll be solved. And it's not necessarily true.
What does it mean, though, for the future? Where do you think we're going to be in 5 years, let's say? And what should manufacturers think about?
Well, undeniably, deep learning will be applied to more task areas, more narrow areas, which will allow new sorts of products. Some will be in manufacturing, some will be in elder care, some will be in social media. There will be new applications. I don't think we're good at knowing what those applications that really work well. I don't think anyone was really thinking that speech understanding systems were not working well because the front-end phoneme processors weren't good enough. They saw the problem as the back end of speech understanding. It turned out it was the front end, the early processing, and that's where deep learning had a real impact.
Explain that a little bit more.
When we speak in a particular language, there's a particular set of phonemes that make up that language, and extracting them in the presence of noise or, as you see with an Amazon Echo or a Google Home, they have deep field understanding. So until recently, you had to be right next to the microphone for the processing to get those phonemes accurately with very little noise. Now you can be many feet away where there's a lot of echo going on. There's a lot of other noise going on.
Like here, kids in the background.
Like here, you can, the listeners, interestingly, the listeners can probably understand that we're in a room with high ceilings. We actually pull out a lot of signal from a sound stream. Anyway, that early phoneme processing, and it's different for every language, so you have to train separately for Hungarian than you would for English and for French, etc. Extracting those phonemes has made the real difference to the speech understanding systems.
So what does this mean for the future of work? Where we are with automation and AI?
Well, I've come to appreciate these two authors and the things they've said more and more. Ray Amara, who was a futurist, passed away in 2007. He was president of the Institute for the Future in Palo Alto. He said, we generally tend to overestimate a technology in the short run and underestimate it in the long run. So I think right now we're overestimating the effect of AI and learning, etc., in how quickly it's going to displace jobs. Yes, it will displace certain jobs, absolutely, but it's not going to get rid of them all in the short run. If you go back to the 60s, people were thinking when the first digital computers were around, they're going to get rid of all jobs. So that people overestimate it in the short run. But if you look at science fiction from the 1960s, they totally underestimated computers in the long run. You know, you look at Star Trek, and they were talking about 300 or 400 years in the future, and the computers they were talking about 300 or 400 years in the future look like bizarre little toys to us. It's nothing like the power of computation now. So they totally underestimated in the long run while overestimating in the short run. I think we're doing that with AI right now. We're overestimating that it's going to change everything all at once, and it's really hard to see the real impact it will have 50 years out. And this brings me to the second person I want to talk about, Arthur C. Clarke, a science fiction writer, the inventor of geosynchronous communication satellites. He wrote the first paper about that. He's got 3 laws, and his third law is any sufficiently advanced technology is indistinguishable from magic. And I think for people who don't have a really good understanding of AI, who are not AI experts, they look at some of these things this deep learning systems can do, and it's so inexplicable that it becomes magic. And once you lose the intuitive understanding of it, magic can do anything. And so now AI can do anything. And I get into arguments with people who say the AIs are going to collude amongst each other and take over the world. And I say that's not going to happen for a long, long term because, we've got this capability, but there's 27 other capabilities we have no understanding for. And they say, you just don't understand how powerful they are. And I think that's a magic argument.
I do recall seeing Errol Morris's film Fast, Cheap, and Out of Control. And in the trailer, in fact, they pulled it out. They had you saying, there may not be a place for humans in the future if we're really successful.
That's the long run. That's the really long run. And by the way, that movie came out late 1997. He shot that in 1992.
That was a wild movie.
It was a wild movie. Yes, it was a wild movie. I was talking from principle and in the long run. But I don't think we're going to see, for instance, self-driving cars where we've got level 4 autonomy, where the driver doesn't even have to be in the car, even in a particular geographic domain, certain set of streets. I don't think we're going to see them in 5 years or 10 years. But 50 years from now, I think people will not be driving cars at all. But it's not going to happen overnight in the way some of the Valley people talk about.
Right.
It's going to take longer.
I think Alon just said it's going to be in 2 years.
Well, yes. Now, I was present when he said that, and giving him the benefit of the doubt, he said we're going to be able to have a car drive across the country without anyone touching the steering wheel. Well, in 1997 or 1998, Carnegie Mellon, in their No Hands Across America project, had a car drive from coast to coast where for 98% of the way, no one touched the steering wheel. That's 20 years ago.
Yeah.
So it's not like it's coming out of nowhere. This has been a long, long tail of development. And he's only saying driving on the freeway. He's not saying driving through Central Square in Cambridge with all the pedestrians. Right. He may believe that, actually. I think he doesn't quite get the distinction. But I think the generalizing from special cases to the vast number of common cases is going to be much harder than people think.
Mm-hmm. But in all seriousness, I mean, it does seem like there's a lot of fear right now, not just in AI taking over the world, but automation taking over jobs, and both mostly at the blue collar sort of repetitive job level, but also potentially at the more creative levels as well.
Yeah, and we will see that. We will see that, and it's something to be scared of. I think, for most of human history, technology has changed jobs, but it's been at a scale of over a lifetime. Mm-hmm. The new technology comes along, and it takes 50 years, 200 years to propagate. So it's not happening to the individuals in the same way it's happening today.
So some people have proposed that we tax robots to slow the development down.
I think people are missing the impact of the demographic inversion that's happening. I'm afraid that there's going to be too many jobs available, but they're all going to be in elder care, because the baby boomers are starting to get retirement age. In Japan, we're changing from a historical society where there were 9 working age people to every retired person to a society where there's between 1 and 2 working age people for every retired person in Japan. Who provides the services to those elderly people who are living a lot longer because of medical progress, but they're weak, they need other sorts of services? Japan is very strict about no immigration. Europe and North America is becoming stricter about no immigration, so that old panacea isn't going to work. So I think there might be an enormous number of jobs, but it's going to be looking after old people and help them go poop, which isn't going to be much fun for those people. There's plenty of jobs, but people won't want those jobs. So I think we're going to need robotic technology to let the elderly maintain their dignity and independence longer.
That's kind of sad, isn't it?
It is.
Did Maya Matarik work for you?
Yes, she was one of my students.
Yeah, okay. She's in USC now, obviously doing socially assisted robots and all that. So,
but she's doing it at a interaction level, not at a physical level of assistance.
Oh, okay.
Yeah.
Meaning more the communications.
The communications, yeah. Yep.
I have a few questions around like the how-tos. One is, for a smaller business, is there a use for automation and robotics? Is this really more for larger companies?
Our smallest customer was a 9-person plastics factory in Tennessee.
Really?
They had no automation, they had plastics machines, but they didn't have automated equipment. Their first piece of automated equipment was a Baxter.
So they start with 9 people, and then what happened once they added Baxter?
Then they were able to do more stuff.
They didn't lay anyone off.
Yeah. And we see, actually, it has been heartwarming, I must admit to me, that what we've seen in the smaller places is it tends to be the person, someone becomes the robot wrangler. And it's someone who previously was just doing a repetitive job, but they're the one, they step up and they become in charge of the robot because there's no one else to be in charge. It has to be one of the workers. And sometimes what we see is other workers saying, hey, can you get the robot to do this task that I hate? Because, in the small factories, they're doing lots of different tasks. And some tasks they really don't like. I remember one where in a plastics factory again, where the things that came out misshapen in the mold need to be ground up so that material could be reused. and they hated it because they had to wear a mask. They had, it was dust everywhere. And so Baxter was the thing that fed the machine, grinding up the misformed pieces of plastic. And that was introduced by the workers on the factory floor. Oh. That's what they wanted it to do for them. I like stories like that, actually.
Those are good stories. So It seems like an expensive piece of equipment to be grinding plastic.
Well, otherwise this is a person.
Yeah. So how much do they cost?
The Baxters were $25,000. The Sawyers, $29,000.
So what can we learn from your experience in getting customers to adopt technology?
Well, I've seen this again and again. It's not going to work if you convince the CEO, and the CEO then says, go make it so to people below. You've got to have champions who really want to use the technology, who really want to be involved with the technology day to day. Otherwise, it doesn't get adopted because, the CEO thought it was a good idea, but I've got my quotas to make. I'm not going to spend time. I'm going to resist it in every way I can because it's not going to help me with my bonus or just my satisfaction of getting stuff out the door. So it really does require the level of the person who's going to be with the robot every day, buying into it being useful. And that's probably true for most technologies on the factory floor, I would guess.
So number one, you need a champion.
You need a champion, yeah.
And then are there other sort of steps?
Well, the other things that we really look at is don't try to do something too hard. Don't try to do something ambitious. First, get to know it. Try to do something that's going to work, because then you'll be able to say, see, it works. And see, I did a good thing. The ROI is paying off. It didn't slow down any of our production. It was seamless. All those good things that you need because of the nature of manufacturing and the conservatism that it therefore brings. You need to have success stories.
Anything else in that process?
We've just brought out a new software system. And the new software system makes everything transparent if you want to look. For bigger companies, when it was trained by demonstration and they couldn't see inside the robot and see what was actually going on, that made the engineers very uncomfortable. So now we've given them complete transparency. And we had to redesign it because transparency for the old thing would have been like a tangle of spaghetti. So we had to start from scratch. We spent 3 years. We had about 60 people working on this for 3 years without telling the market that we were doing it. That has, for the larger manufacturers, that has just said, this is what we needed. We didn't know how to trust the old thing because we couldn't see what was happening inside. Now we can see exactly what's happening.
So what does it look like then? How do you see that? What do you see?
Well, in the old software, all you saw was a 2D map of the work environment with various icons, meaning there's a pickup over here that's put down over there, whatever. Now, if you attach or use a second screen, a PC, a laptop, and look inside, and still trained by demonstration, and it doesn't feel a whole lot different on the screen of the robot. But if you can look inside, you can, one, see a full 3D simulation of the robot, and you can fly around in 3D, see where everything is. When the robot looks at a fiducial marker and works out the local coordinate system for a tray, you see tray of parts. You see in the 3D simulation exactly where that tray of parts is. It jumps, as the robot sees it. And then there's an explicit representation of the task in something called a behavior tree. Now, behavior, back in the 80s, I developed something called behavior-based robots. And that was the basis for the Roomba and lots of other things. Around 2000, Bruce Blumberg, who was a professor at the Media Lab, but has worked at Rethink for 6 years, with one of his students, Damien Isler, and it was really Damien's thesis project, generalized behavior systems to something called behavior trees, which subsumed a bunch of other systems. And then behavior trees have since become a dominant programming methodology for games.
And if I remember correctly, it's like really breaking down the tasks into different pieces that you can combine.
And you can have, it's a tree, you can have series nodes where things happen sequentially, parallel nodes, so there can be lots of things happening all at once. But it's a very structured representation. You can see exactly what's going on. You can have debuggers around it. You can stop it. You can look and see what the next step is. And it makes everything totally transparent. And then we built that with a web server in the robot. And so on your second screen, there's Node.js, JavaScript, doing a completely modern user interface with crisp graphics, being able to go in and change things. And what's the competition in automation equipment? It's things from the 80s that look like they were user interfaces that look like they were built by mechanical engineers in the 80s, because they were.
Wait a minute, I'm a mechanical engineer from the 80s.
Yes, but if you had built a user interface in the 80s,
yeah.
Do you think that looks like what people expect of a modern user interface?
I would not be proud of that anymore.
Right. And that's what I'm saying. It got locked in.
Yeah, absolutely. Tell me about your 16-year-old self.
When I was 7, my mother, I was in Adelaide, Australia, and my mother bought me 2 American books. They were called How and Why Wonder books. And one was on electricity, and one was on computers and giant brains, from which I learned the binary system when I was 7. So starting age 7, I tried to build computers out of flashlight bulbs, batteries, cutting up fruit cans to get strips of metal to make switches with nails, wires. When I was 7, I did build a machine that could play a certain game and beat everyone. But when I was 12, I had a machine that could play tic-tac-toe and beat everyone. I always wanted to build robots, but I wasn't good mechanically good enough. But by the time I was 16, I was starting to build robots, which was still not very good mechanically. But at least by that time, I was able to do the mechanism. And I was by then building transistor circuits and able to control them in interesting ways. So I spent my time, we had a shed in the back garden, and I would spend all my time down there building computers and robots. So, that was what I did all summer.
I hear the chicks dig that.
Yeah. Yes, exactly. So that was my 16-year-old self. Then when it came time for college, which I entered right after I turned 17, there wasn't any computer science, so I studied pure mathematics and actually I entered in February of 1972. The academic year fits the calendar year in Australia. And the university was 6 years old at that time, and the mathematics department was filled with actual refugees from the Prague Spring. So I had a classical Eastern European mathematics education from Czech and Slovak mathematicians.
No,
it was fantastic.
Oh my God. So what did that mean? How was it different?
It was all about continuous math, never diagram, everything in symbols, everything, I took 41 courses as an undergraduate, 1 in physics, 1 in chemistry, 39 in mathematics.
Really? That's
Yeah.
crazy. Did that influence your development of all the different theories and the technologies?
Well, it gave me a strength in mathematics. And I used to sort of make fun of people. I say people, computer scientists were always trying to have lots of math in their papers, because they felt a little, they had to prove they could do it. I never felt I had to prove I could do it. So it gave me a lot more freedom. But by the way, along the way, at this university, the mainframe computer was a 16 kilobyte IBM 1130, which had 4 full-time operators during the week. And you put your deck of cards in, and 24 hours later, you got your printout. A professor named Jaroslav Kalski, one of the Czech professors, and I just found out last year when I was back, and he's quite old now, that he has no memory of this. But somehow he decided that my interest in computers should be helped along. So he arranged that for 12 hours every Sunday, from 9 a.m. to 9 p.m. when there was no one in the computer center. I got that computer to myself for 12 hours every Sunday. And I built virtual memory systems. I built operating systems. I'd read a little bit. So while I was doing this classical mathematics during the week, on the weekends, I was teaching myself computer science. And Jerry just doesn't remember it. I thanked him publicly when I was back there last year. And after he came up, he said, I don't actually remember doing that.
But how does a nerd like that become a successful CEO?
Well, I'm not CEO, by the way. I only have a CTO, but I was
CTO,
director of a 1,000-person lab at MIT. Painfully so. When I went to Stanford and did my PhD there, I was just horrible at giving talks. I was such an introvert. I came and was a postdoc at MIT at the old AI lab, where the AI lab was fairly small at that time, 1981. There was something called a playroom around which there were offices, and the expectation was the postdocs would give talks. And I just got thrown in, give a talk, give a talk, give a talk. And it was painful at the start, but somehow I learned how to communicate, and I think learning how to communicate was key.
When did that light bulb go off?
Sometime in that first 2 years I was there, I got much better at communicating, and partially it was because I was good mathematically, and I had learnt to program everything at every level. So I was able to very rapidly build algorithms with graphics on the LIST machines and do stuff which surprised everyone in robotics. So that was encouraging that I was able to do things quickly.
I'd like to ask 3 other questions of everybody. For you, looking forward into the future for Rethink or your work in general, what does success look like?
So at Rethink, it's definitely been an artistic success. And let me give you an example. 4 years ago at the Automate conference in Chicago, big trade show, there were no uncaged robots. We had Baxter there. We wanted to show it uncaged. So the safety people said, you cannot have an uncaged robot. We had to go through a process where we had Baxter hitting us in the chest again and again. Finally said, okay, you can have an uncaged robot. You're the only ones. This year, 4 years later, there were hundreds of uncaged robots.
Wow.
So we have changed the conversation of what a robot is like. It no longer has to be in a cage. That is an artistic success. And everyone is talking about collaborative robots. I don't believe that collaborative robots are anywhere near as collaborative as ours, but it's changed what everyone says is the future. We need to become a true financial success to get completion.
And what is that success? What does financial success look like for you?
Yeah, I hate to give a number, but somewhere 100,000 industrial robots a year are sold. If we're selling 10,000 robots in a year, then that says we've captured a big part of the market. We've changed it. So some number like that. I don't know exactly what. When I came to the United States, I knew of 3 mobile robots in the world. iRobot has now sold 20 million mobile robots. So that feels like a success.
I'd say so.
To me. So changing the numbers.
So in that pursuit of that, what's keeping you up at night? What's the biggest challenge?
For the biggest challenge for Rethink Robotics?
Yeah, or is there anything that do you have doubts about that?
I don't have doubts about it, except how long it will take to, because I've seen how we have changed the conversation. Everyone now thinks that they can have robots that are uncaged. It's about them deploying them that becomes important. And so over time, we've tried to knock down each of the, what I talk about is what is the friction point for someone buying one of our robots and deploying it. The first friction point was that you couldn't get a straight answer on price. You'd have to say, I want this robot, and then there'd be this whole negotiation about what it would cost. So we just made a price list, which was a completely radical thing to do for industrial robots.
Really?
A price list, yes.
Why?
Because that was never said. It was always going to be a deal. It was always going to be it was a different sort of sale. Next thing was getting rid of the cages. Next thing was getting rid of an old programming language and just having trained by demonstration. Next thing was dealing with PLCs, programmable logic controllers. So we've brought that logic into the robot. That's much easier. What's the biggest friction right now? Getting the right gripper. We don't have good robot hands. Grippers are still Blackheart, we now sell a whole bunch of gripper kits and what we call Click Smart, which is an easy way to put it onto the robot and have it in the tool plate, which follows some ISO standards, have it have memory, have it know what's going on. And with our gripper kits, about 80% of applications can use our gripper kit to get the right gripper. But it's still, someone has to think about it. Someone has to design the gripper from the gripper kit. It's not as friction-free as I would like.
No pun intended. The last question is, if there's one thing, what's the one thing you wish you had known or that you might advise other entrepreneurs that are launching a business?
From my previous life, have a customer, which seems pretty obvious, but I was an academic and that thought never occurred to me because I was used to going and pitching wild ideas to DARPA and convincing someone to give me money. Have a customer.
Do you miss academia?
People ask me that all the time, and honestly, I don't. I did academia on a big scale and ran a big lab. I think it's better for people to do different things in life.
And what does that mean to you? What does that mean?
Well, it means, I was an academic. I also had companies. I could have stayed with iRobot and continued on there, but I chose to do, and the next company to be something doing very different. I've taken up long-form blogging recently. I will probably start writing some book-length things pretty soon. So I'm going to be doing some different things that I haven't done for a while and see where that leads.
That's great. And how do people find you? Tell us about the blog link.
RodneyBrooks.com. Go to RodneyBrooks.com and you'll see a link to the blog and various pieces. There's long-form essays, there's short takes on science papers, and there's whimsical little things.
Fantastic. So great to actually be able to sit down with you. We keep running into each other and in so many different circumstances and seeing how your path really has taken you all over and so many great things. So thanks so much for spending your time with us.
And thanks for talking to me.
A couple of days ago, I read an article on how China is becoming a world leader in robotics. I already sort of knew this, but the article said that by 2020, they'll be producing half of the world's industrial robots. What struck me the most about the article was how the Chinese government is so eager to keep production in their country that they've been providing huge incentives for robotics companies. And meanwhile, tech leaders like Bill Gates are suggesting that we tax robots. It's fascinating to see the difference in attitude. Well, my conversation with Rod casts new light on the issue for sure. I think that the three most interesting lessons I learned today were, first, with all the talk about saving jobs from automation, it's clearly a more nuanced issue. There's a pending workforce shortage in some places that are manufacturing powerhouses like China. Although it's a little less pronounced in the US, there's definitely a big skills gap, with skilled workers about to retire and the younger generation uninterested and untrained for the manufacturing industry. So maybe the solution is a combination of workforce training and cooperation with robots. Not to mention, I think we need a hefty PR campaign so people see the potential for jobs in manufacturing. Also, we talked about the challenges of customer adoption. You may recall how Nick Pinkston decided to create his own fully automated factory because he didn't want to have to convince existing manufacturers to do anything new. Well, Rod is facing the beast head-on. The key has been finding champions within the companies and starting with small wins. The company has really changed the conversation around industrial robots, and I'm excited to see that leadership turn into financial success. And finally, I loved hearing Rod's perspectives on artificial intelligence. Who knew that the front end of speech technology would be the key to AI adoption? That, along with deep learning and big data, makes today a really interesting time to be alive. By the way, today's conversation underscored something that's been bugging me recently. Speaking as an American, I think we have a love-hate relationship with manufacturing. What do you think? I mean, we talk a lot about manufacturing bringing back jobs, but then people get skeptical, so we don't want to support it. What we forget is the impact manufacturing has not only on direct jobs, but on so much else. One recent study by the Mappy Foundation found that every job in manufacturing creates another 3.4 jobs in the rest of the economy. Not to mention, we depend on manufacturing for our goods, and it's a huge national security issue if we don't control the means of production. In addition, we lose our competitive edge and our innovative capacity if designers and engineers aren't working with the production lines. Here in LA, it's been so powerful to see how products evolve so quickly when they're made locally. Rod talked about the deep supply chains in electronics that we lost to China and the expertise that Eastern Europe has in motors. Fortunately, we still have our expertise in certain things in the US, and we need to keep investing in the research and the workforce to keep it at the cutting edge. Without manufacturing, we simply become consumers that depend on the rest of the world to feed our appetite for stuff, and that's a dangerous position to be in for sure. So what do you think? How can we better invest in local manufacturing? Should we be encouraging robots or taxing them? Do you believe that technology will improve our lives, or are you starting to get a little bit nervous? Or are you flat-out terrified? It's a complex issue for sure, and I'd love to hear your thoughts. If you like geeking out about this sort of thing, join the Art of Manufacturing Facebook group and join the conversation. By the way, if you're in town next week, I'll be moderating a panel on how we make at Platform in Culver City Thursday, June 15th. I'll also be emceeing the next Make It monthly event about product strategy in downtown LA on June 28th. We'll have 4 experts sharing advice and doing deep dives with 2 entrepreneurs live in front of the audience. For more information, check out the events page at makeitinla.org/events. Time to wrap it up for the Art of Manufacturing. Tune in next Thursday for our final episode with Courtney Nichols-Gould, the CEO of Smarty Pants Vitamins. She has tons of great insights from her journey from successful digital entrepreneur to building her first manufacturing company. Visit makeitinla.org for show notes and to stay in the loop about events, news, and resources. To chat with other like-minded manufacturing entrepreneurs, join our Facebook discussion group at makeitinla.org/community. Never miss an episode. Subscribe on iTunes, Google Play Music, or your favorite player. And if you like the show, do us a big favor and leave us a review. Or send us a message with feedback and ideas on Twitter at WeMakeItInLA. This podcast is produced by At Large and Dangerous in collaboration with the Make It in LA initiative and other partners. A big shout out to Peter Brandenburg, the producer and audio engineer, and our content coordinator, Heidi Carrion. Thanks for listening to The Art of Manufacturing. I'm Z Holly, and remember, don't just make it, make it.